So good evening everyone, bonsoir à tous et à toutes, and welcome to tonight's presentation of RTF Connects, titled Creating an Effective Critical Math Inquiry with Maria Van Vallis. We have a fairly small group tonight with a good mix of experienced participants, and Maria is also extremely experienced and one of our most talented facilitators. So I think that it should all go very smoothly tonight. It's always wonderful to meet all of you over RTF Connects from all across the province, mostly actually to the south of the province at this time. Je voudrais profiter de l'occasion pour souhaiter également la bienvenue à nos collègues franco-ontariens. Comme à l'habitude, cette session est en anglais, mais si vous désirez, n'hésitez pas à me contacter en français par la suite. We are definitely thrilled to have each and every one of you with us tonight, and it's also our absolute pleasure to welcome Maria Van Vallis. Maria is a member of the Critical Thinking Consortium, also known as TC Square. She has taught at a variety of levels and has extensive experience in integrating critical thinking strategies in the classroom. I've moderated for Maria in the past, and I think that she's truly a fantastic facilitator in the true meaning of the word. She is a true catalyst, able to generate and foster engagement and participation. I think that we are all in for a treat and a wonderful session tonight. And please don't hesitate to share your ideas, questions and suggestions all along her presentation. You can also learn more about Maria and her work by visiting the TC Square website. I will post the link to that website in our chat box in a few seconds. But at this point, I will just pass the microphone to Maria and let her keep introducing herself and share her ideas and experience with all of us. So Maria, please feel free to click on your talk button anytime you wish, and then go ahead. Thanks so much.
Thank you so much for that generous introduction, Michelle. I'm very excited to be here with you tonight, and I'm always thrilled to work with Ontario's dedicated teachers. Here you are on a Thursday evening. I'm sure you've had a very full day, and yet your desire to continue learning and your dedication to students is why you're here. And so I just want to really honor and acknowledge that. I have been teaching for over 16 years, and I really want to tell you a little bit about my stance, because I am one of those teachers who, while I did very well in math, when I did get a teaching job, I had considered myself more leaning towards the arts and social sciences and geography, English, and math became one of my teaching assignments. And there was a real process of learning and unlearning that I had to engage with. And I really committed myself to that process because I didn't want my students to be denied any opportunities for deeper understanding or for engaging with the subject because of my own inadequacies. So I really dedicated myself over the last over a decade. And so I'm happy to share with you some of the learning and to share with each other, because I know that as we're really trying to understand what does it mean to do math with an inquiry stance, this is part of the shift that we're really participating in. And the work of the Critical Thinking Consortium and of my colleague Laura Jeannie Newman has also been really instrumental for me, and so I'm happy to share some of the things that go on. This session is a little more geared towards the intermediate that was in the description, but if you are a junior teacher, I think that you'll still find some of the principles, even though some of the examples may be more intermediate based, I still think that some of the principles we're talking about are going to be worthwhile. So I wanted to start off asking you, because we have such a wealth of experience in all of you here tonight, I wanted to ask you how you create meaningful opportunities for inquiry in mathematics. And if you want to use the tool that Michelle had outlined, the text tool, and write directly on the blue box that's here on the screen, that would be wonderful. If for some reason your text tool isn't working, or you might be on a device that doesn't allow you to, then please feel free to put it in the chat box and I'll be sure to read it out to everyone. So take a moment and think about how are you creating these meaningful opportunities? And if you're just starting in the process of inquiry, then please share that. It's really good for all of us to just know where everybody is as we're getting started here tonight. So some of you are looking for opportunities in literacy, videos, cross-curricular learning, using open-ended tasks. Sometimes it's just looking out the window, yes, and seeing something neat and just sparking a provocation. That's wonderful. Using complex problems that often require students to go beyond their current understanding. Cross-curricular, looking for provocations, Lisa's saying, that genuinely elicit questions from students. Introduce new topics through investigation and discovery. Pictures that promote students to ask questions. Providing open tasks. That's great. Thank you. Just want to make sure I've captured everybody's thinking. Providing tasks that are meaningful and relate to real life. So again, we have a group of teachers here who are clearly really trying to engage their students in this amazing discipline. So tonight what we're going to explore, you'll notice that the title of this webinar is around creating an effective critical inquiry. And that's what we're really going to focus on tonight, is to look at this particular form of inquiry and help us gain a deeper understanding of what this means. And our guiding question tonight, one of the questions we're really engaging in through the course of this the next 90 minutes that we're together, or now 80 minutes, is what might an effective inquiry look like in mathematics? And I want to invite you right now, if you have a piece of paper beside you, or even your computer, to open up a page in Word or another text application, and just spend 2 minutes. I'm going to ask Michelle to put maybe 3 minutes, actually, if we could get a 3-minute timer, to just jot your initial thoughts down about what might an effective inquiry look like in mathematics. I want you to think about, as you're writing down your thoughts, what might it look like in terms of student engagement? What might it look like in terms of the outcomes for students? What might it look like or sound like or feel like in your classroom when you are engaged in an effective inquiry? Right? So really take some time to think deeply about how do we know, how might we know that something is effective, that an inquiry stance that we're taking is really nurturing the kind of disciplinary mathematical thinking. So notice someone's written about productive struggle and small groups investigating a question of intrigue. And the aha moment. Beautiful. And I think what we're doing right now, what we've just engaged in, is creating a thought space, right? We're creating our own thought book, our own thought space, so that we can deepen our understanding as we go through tonight. There's broadly speaking about 4 different versions of inquiry. There's the inquiry that is research. So this is when we have a very factual question, who was Archimedes, right? Inquiry is research. What are the dimensions of a triangle, right? We have inquiry as personal expression, so it's personal preference. We have inquiry as discovery, so the kind of questions that invite speculation, so those really big open-ended types of questions like how large are numbers, right? That might be something we invite younger children in, or how do we know when we're right? So the inquiry is really more that discovery-based. When we're guided by personal preference questions, it might be something that really you are interested in. So how might I better understand how to do something? So there are these different stances. The stance that we're really going to focus on tonight is the inquiry as critical thinking. So these are the kinds of questions that require reasoned judgment. Okay, so we're going to just spend a little bit of time making sure we're really clear on what we mean by that. So we're talking tonight about critical inquiry. And so a number of people have mentioned these other stances, and I want to be clear, really clear, that I'm not saying that these other stances are wrong and the critical inquiry is the right one. But I do want us to just explore together tonight what the critical inquiry stance involves and what it might offer to us as teachers in nurturing mathematical thinking. Because it is the inquiry the inquiry is critical thinking, the critical inquiry, that is the kind of inquiry that leads to the deep understandings of a discipline, of a subject, of a concept. We're looking at creating that thinking classroom where the students are learning to think and they're thinking to learn. The thinking is not an end of unit task, but it's the methodology. It's the way in which we're learning. It's the way to engage with and deepen the students' understanding of the subject matter that's embedded within the curriculum. And the framework that at the Critical Thinking Consortium, over a few decades now, and the consortium is made up of partners, which is teachers, principals, superintendents, stakeholders within the education system, professors within universities, to really refine this understanding of, if we're trying to teach quality thinking, what does that mean? How do you do that? How do we actually teach the tools of thinking? So when we're creating that thinking classroom, we're trying to shape the climate that actually supports thinking. We're trying to create opportunities for thinking by virtue of the way we design and frame our tasks and questions. We are intentionally building student capacity to think, and the kind of guidance we provide, the kind of assessment feedback that we provide is really to inform students around their thinking. And you'll notice along the bottom the 5 intellectual tools that are always at play whenever we are thinking critically. Okay, and we'll talk about those tools. You know, I have done other sessions that really just unpack and explore those tools, but for tonight, we're going to focus on some of them in different ways and come at them from various entry points. But essentially, it's important that we understand that when we're thinking critically, we are engaging in the tools of thinking. Here are some of the dimensions that are involved when we're creating the conditions for critical inquiry. Here's some of the dimensions of what we're doing. And I want to spend some time tonight trying to unpack some of these, because it can feel like a little bit of an overwhelming list. But I think when we look at each one of these and explore it, we start to understand what's actually involved and how critical inquiry is a particular kind of stance in our classroom. So I'd like you to take a moment and just read through this list and think about, as you're doing so, and you can even maybe again make some notes in your own thought space. Think about what you want to affirm in terms of your own classroom practice. Maybe there's an area you think, oh, I could refine something within one of these components, and what you might even think about what you might aspire to. Okay, so just take a moment to look through this list. If there's anything that anyone wants to say in reading this list or any insight that they might be having, I really encourage people to share in the chat box. Please don't hesitate at any point in the course of the webinar to do that. You'll notice as well that Michelle is posting some links. All of those links will be available when the recording is posted. So just know that those will all be there, but I wanted to give you some background. Tamara, in terms of problematize, that's exactly where we're going to go next. So that's an excellent question, and I'm going to lead right into that right now. Thanks, Deanna. Yes, how we shift the focus of assessment. So what does this mean? How do we frame tasks and questions that problematize the content? I mean, we're in mathematics, so you know, everything essentially is framed as a problem, right? All the mathematics comes at us. So what does that look like? Could we refine that a little bit to really bump up the thinking in mathematics? So I'd like you to take a look at these 3 types of questions and think about what's the difference between these 3 types of questions. And as you start to think about the differences, please feel free either write on the slide itself above or below or within the chat box. Please write down your thoughts about what the differences are between these 3 types of questions. Okay, I love the point that was just made here around the starting point of the class. How the teachers, I don't know because your name's not attached, but whoever's written this insightful comment, this is a really real concern, right? You want to jump to type 3, but some students may not be there. So we're gonna look at that, right? We're gonna look at that. Someone's written type 1 is not an open-ended, simply recall. Type 2, the yes/no. Type 3 is a thinking question. Yeah, so the type 1 questions, I affectionately refer to these questions as the Where's Waldo questions. An answer exists. It's just a matter of figuring it out or finding it, right? So you could look up a definition of prime numbers and then use that to figure this out. The type 2 questions, it's really personal preference. There's no right or wrong. Do you like learning about number theory? No. What are we going to say? Do you like learning about number theory? Yes. So, so those are the personal preference. But as a number of you pointed out, the type 3 are more of the, what we call the critical thinking questions. There is some inquiry involved to answer this question. There is more than one right answer. Doesn't mean that every answer is a good answer, but there is more than one right answer to this question. And the answer, it demands a kind of reasoning or justification, right? So that type 3, so we think about, and again, want to be really clear, type 1 and type 2 are not bad questions. They're questions we're going to ask. They're questions, you know, what we do as teachers are ask questions. But as we start to make the thinking questions more explicit, we can be more intentional about how we're framing to problematize. So coming back to the point that was made, notice that here we haven't asked what is prime factorization. We haven't asked what the greatest common factor is between the two numbers. Both of those are problems, and they're, you know, they're important things to know within the discipline. But notice the kind of thinking that this is requiring a student, and we're thinking about those intellectual tools to know what prime factorization is, first of all, to have a strategy for figuring this out, using the criteria of an effective method for determining the greatest common factor of two or more numbers. So this question has been tweaked to invite that kind of deeper thinking. But this point that was made by teachers is also really important. You want to ask this question, but some students may not be there. So we're gonna look at that. I promise you over the course of our time together and think about what does it mean when we're trying to ask these kind of questions and we're not sure about where our students are. So there are many definitions of critical thinking, and this is not the definition, but I do think that that the consortium has developed a very pedagogically useful definition, right? One that's really useful to us as educators. Because now we can start to understand that critical thinking is when we're thinking through this problematic situation about what to believe or how to act, where we're forced to make the reasoned judgment that reflects the competent use of those intellectual tools for quality thinking. Okay, so let's unpack this a bit. Let's just go back to our question for a second, type 3. This student, any student who's answering this question, this is a problematic situation. Is prime factorization always the most effective method? Right? Like, how are we going to find out? How are they going to find out? Now we have this criteria of most effective. So that criteria is what creates the demand for a reasoned judgment in a way that the type 1 question doesn't, right? The type 1 question requires some knowledge or the ability to find that knowledge, but the type 3 has that criteria that really forces that kind of reasoned judgment. So the kind of thinking, the cognitive demand is at a different level. These are the attributes of a critical thinking question. So when we want to bump up the thinking, these are the attributes. The question needs to provide or generate options. Students must identify or consider the options. It requires that reasoned judgment where you've got to arrive at a judgment or conclusion or decision that is reasoned. It requires that you use the criteria for making your decision. You have to assess different options. So in that case of the prime numbers, you're assessing the most effective strategy, right? You're using the criteria of effectiveness to help you decide. And it requires the use of evidence to support that judgment. So this is, at times, we might be more comfortable if those of us who might be teaching, social studies or other disciplines, but to really apply this in mathematics, now to think about, well, what does that mean? What does that look like, right? To really create these critical thinking mathematics questions. Aren't all mathematics questions inherently, thinking questions? I would say yes, they do require some thinking, but as we saw when we identified the 3 types, some require a different kind of thinking. And what I want to put forward is that when we invite students to that deeper inquiry, that deeper critical inquiry, they actually learn and gain the deeper conceptual understanding as they're thinking through it. Right? And you could see that between the 3 types. I'll just go back to them for a moment. I want you to just think for a moment about what will students need to know and learn to be able to answer these 3 questions? Where will they be engaging in a deeper understanding of the discipline and the concepts involved? Again, when we're creating that thinking classroom, we want to create more opportunities for that kind of thinking. Just wanted to do a little check-in, make sure is everyone with me? Any questions right now? Everyone doing, maybe you can give me like a check mark if everyone's good. I just want to make sure we're all good. Okay, great. Now, I'm not going to spend too much time on this tonight. Again, I've done some sessions. Sorry about that. That's my phone in the background. I'm not going to do too much on this tonight, but I have done some sessions specifically on the 6 different ways we can invite critical thinking. So I just wanted to put this out there that this is worth exploring, the 6 different ways you can frame a question, that you can frame a decode, and we will look at these. But again, it takes some time to really dig in. Decoding, judging the better or best, performing to specifications, critiquing the piece, reworking the piece, and designing to specifications. So these are 6 ways. So when you're trying to design, and that's what I really want to point out too, is that you can take an existing question from a textbook, an existing open-ended question, a test question that you have, an assignment question, something that you like, and when you really understand these 6 ways of framing a question, you can tweak it and bump up the thinking immediately, right? And it takes some time to get familiar with these 6 different ways of framing. So we will look at some examples, right? So in the first question, let's say a common question that I would ask in math class would be, what's your solution to the question? But even in that consolidation, I can bump it up and make it more of a critical thinking question. So critique the piece, right? I'm trying to decide which is more or less of something. Decide if a solution strategy is effective. Or if I'm judging the better or best, choose between 2 strategies, which is more effective. So this can be really powerful in consolidation in mathematics. You actually put 2 different strategies on the board, unpack a little bit of the criteria, which I will show you about effective, and ask the students to think about which of these is more effective. Reworking, well, let's take this strategy and make it more effective. How would we do that? When we're decoding, we're trying to figure out or solve an enigmatic situation. How does this solution strategy work? And then designing to specifications is when we're, in this case, here's an example, create an effective solution strategy to a similar problem. Perform to specifications I didn't include that example here. It's not always one that we use as much in mathematics as in some other disciplines, but certainly we can. But that's something that really happens in real time, right, where we're performing something. So these are some examples of the 6 prompts. Again, 2 effective frames that automatically bump up the thinking. A lot of times now, I've told my students I'm not going to be an extension of their brain. So when they come to me and say, is my answer right? The first question I'll say back to them is, does your solution make sense? Does your strategy make sense? Does your answer make sense? I'm trying to build in them the capacity to be able to assess, to critically assess their own strategies and solutions and answers. Or another, again, simple frame, which of these is more or most effective? Which of these solutions is more effective? Which of these strategies is more effective? Which of these approaches is more or the most effective? Right? Simple ways we can just bump up thinking and tweak using those 6 prompts in our questioning stance. Which proof is most effective, right? And again, providing students with some different examples. Obviously, this is more of a secondary example, but just to give you the sense of, think about the kind of thinking that this question invites versus, is this proof right? Okay, the difference in what is the cognitive task that we're asking of the student here? Again, here's some, the task of checking answers. Is your answer correct? But what if we started to ask, how do you know that your answer is reasonable? What evidence, what clues, what inferences allow you to provide the answer with some certainty? Right? So getting students to find, where's your evidence in your solution? How do you know that you're right? How do you know that this is a reasonable answer? So we've taken an open-ended question, and we haven't tweaked the question itself. So we've got our open-ended question, what do you know and what can you find out about the number 180? So that's more of a discovery inquiry stance. But we can still bump up the thinking with a critical inquiry stance in our consolidation, right? Or as they're working through it, we can bump up their thinking. When we ask the question, which strategy is most effective? Well, what might be some possible criteria, right? Can anyone think of some, you can just write in the chat box, what might be some examples of criteria for a strategy being effective? What would be an effective strategy? Can anyone feel free to put some of your thinking in the chat box at this point? Right, the most efficient, Deanna, thank you. Yeah, that's really sound. Any other thoughts? The one that works for the student. Clear to understand, thank you, both Brian and Nicole. Okay, so these are some really good ideas. And again, think about in class how you can unpack the criteria, you can co-construct criteria with students. Sometimes you might be the one giving the criteria because of time constraints or the nature of the task, but often it's a really good idea to co-construct, right? Lee says the strategy that allows, sorry, let me go back up there for a second. The strategy that allows for multiple entry points. All the students can access the problem, can prove it is reasonable with another strategy. So great thinking, okay? Again, so we could co-construct this. I'm going to offer some possibilities here. Again, all of your ideas are very good. I always like to say when I'm giving a criteria, like in this case, most effective, I don't like to have more than 3 or 4, anywhere between 2 and 4 characteristics, right, of that criteria. Otherwise, it gets a bit overwhelming for students. So here's some possible criteria for most effective. It's efficient, it's well understood, and it's reasonable and accurate. So if it's efficient, it would incorporate the previous math knowledge to arrive at a solution more quickly. If it's well understood, I understand what they're doing, or a peer understands, or they understand what it is they're doing. And if it's reasonable and accurate, the solution makes sense and leads to a correct answer. Right? So imagine if we post this, right? Like this becomes a kind of anchor chart for student thinking. And anytime they're selecting a strategy, they are constantly referencing back to this criteria, right? And when you're assessing them and providing feedback, it again is really nurturing this kind of thinking. Okay, was that an efficient strategy? How well did you understand the strategy? Did it help you arrive at an accurate answer? And what happens is that students start to internalize this powerful criteria and develop the capacity to assess their own thinking and work. And it's really an amazing thing as we start to see that take hold in our students. So the second dimension of an effective critical inquiry I want to explore a bit tonight is that we're creating these opportunities for students to critically analyze and not merely retrieve or memorize the information, facts, and concepts. And this comes up a lot in mathematics, and there's this kind of unfortunate, dichotomy that's emerged. And there's an article that I will be sharing around reconciling inquiry and the basics, right? And it seems to be this, the students need to just memorize and know, and absolutely we want that automaticity to be there for students. But how will they make meaning of the mathematics if they're not invited to critically analyze the concepts? So I'm going to give you an example of an algebra critical inquiry. Now this is a little bit enriched for grade 8. I have used this in grade 8, and I'm going to share with you tonight like some of the amazing things that happened. So on the very first day, I put this question on the board, and students had a thought space. And they were very, they acknowledged, and we just put it right on the table, that they said, I feel really intimidated by that question. They said, they're like, maybe only 2 people in this class are going to be able to solve that question. And we generated some ideas about some of the concepts. And I asked them, okay, create a little ladder in your thought book, and I want you to rank the most important concepts you think you would need to use in order to solve this challenge, right? Some students are like, I don't know, what's a distributive property, or right? They picked some of the ones they knew, like LCM. I know what LCM is, or bedmass, integers. But this question, both questions, both the algebra question, the algebra equation they're being asked to solve, but the real critical challenge here is that they have to think through the concepts needed to solve. So what's going to happen? And we're going to come back to this example a couple of times tonight because it was quite fascinating. I conducted some action research in my class around this because I'm really, really interested in algebra and those transition years because we know that students are expected to do a considerable amount of algebra once they leave grade 7 and 8. It is working on the complex mathematics that enables those brain connections to develop. So I want to go back to the point that was made by the teacher who mentioned, I want to ask those type 3, but my students aren't ready. So I agree with you. My students were not ready to solve this challenge by any stretch on the first day, not at all. We're going to talk about why there might be some value in setting up a really rich task at the beginning and slowly nurturing and scaffolding the thinking and having the students come back and revisit it again and again to build those deep understandings, to build those connections between ideas. It's what we practice. What we practice becomes what we become good at. If we only practice the rote memorization of those basic facts, and again, not saying that isn't important, but if that's what we spend our time doing, that's what we'll be good at. If we're not engaging in complex mathematics, then the students will never become good at it, right? And then it becomes more and more of a gap that's really difficult for them to enter into. So what you notice I did with this algebra challenge is, rather than make that proof of learning, that question, proof of learning at the end, I'm going to give you this really complex question. You've got to apply all of the knowledge that we've learned along the way in this unit. But the flip is, what about if we make the complex challenge the driver for the learning, so that students start to engage and it becomes the invitation for them to learn, in that case, about the distributive property, about like terms, about integers. That task, the challenge of it, becomes the invitation, right? And what we become the choreographers, right? This idea comes from my colleague Garfield Ginny Newman, right? The teacher is choreographing that learning experience. And what a challenge like that sets up is we move from inquiry to a sustained inquiry. Not just one question, but an overarching challenge that then is supported by a series of inquiries, right? So that some of the power is not in the single question, but in our careful sequencing of the subsequent questions that tumble out of that challenge. So out of that algebra challenge comes questions about, what's the most important function of the distributive property? What's the most important role played by integers? How do we know, how do we determine the most essential characteristics of like terms, right? We have subsequent inquiries that then are all feeding back into that overarching challenge. Okay, so that's a kind of a rich question like this. You can have your entire curriculum cascade out of a rich challenge. Not entire curriculum, but I mean entire core, like curriculum expectations and a lot of specific expectations can cascade out of a really rich challenge, right? And the students become engaged and caught up. And I'm just going to show you an example, and again, I'm going to come back to this, but here's an example of a student's final solution. This is a grade 8 student to that challenge. After we had really sequenced and scaffolded, and she rated the importance, and we had some conversations as well. Right. Here's another student where, again, I want you to think about the thinking that you're seeing here, the kind of thinking about algebra from a 13, 14-year-old student. And these students aren't necessarily, you know, exceptional. Some of these students have, you know, various, you know, challenges that they're working with. But the invitation to think and the scaffolding of thinking, it can unleash incredible potential in our students. Again, looking at her thinking and justification here. This is, I showed you the beginning. There was a real journey and scaffolding we did, but I wanted to show you some of where we arrived with this challenge. And I want you thinking about what do they now understand moving into secondary level mathematics. And what you'll notice there is she's written about thinking like a mathematician. So one of the shifts in my own thinking, in my own classroom practice, has been that I don't think anymore, organize everything according to these discrete units, like I'm doing this strand and this strand and this strand, although that certainly still is an organizer that I pay attention to. But I've decided that my curriculum is really to support students in thinking like a mathematician, and I do that through the expectations for that grade level, right? But what I'm really doing, I used to sort of think, okay, and now I'm doing fractions, now I'm doing, probability, now we have to do this and cover this, and you almost become an accountant of expectations. And the powerful shift is, no, what I'm really doing is supporting students to think like a mathematician thinks. And I'm going to do that through fractions, through exploring complex challenges in algebra, in measurement. Okay, so that's part of the shift, is we want them thinking through the discipline, thinking in a disciplinary way. So you'll see she's actually noting the different ways she applied thinking like a mathematician to that challenge, because this is what I'm trying to explicitly teach now. When we look at this taxonomy of engagement, you sometimes on a good day, if we can get them complying and on task, it's like that was a good day. Sometimes we exhaust ourselves trying to interest and entertain our students. We do always love it when they at least care or appreciate the value. But I think where we really want to aim our instruction, and what we really do want as educators, is to challenge and transform our students through the learning opportunities. And I'd assert that the way that we do that is through designing our task to demand and invite that critical, collaborative, creative, and conceptual thinking. Right? Because then I think you can see the kind of engagement just in the students' answers here. Right? You can see there's a level of engagement and the challenge she's been caught up in, and the transformation in her thinking. Right? And that's why the design of our tasks can play such an important role. Here's another rich task for measurement unit as well in grade 8, where they have to determine the volume and surface area of cylinders as one example of a shape. So again, first day, develop an elegant strategy to determine a reasonable estimate for the surface area of the Guggenheim Museum. And you have the students speculating from day one, right? And starting to say, well, I don't know, how do you measure like circular things? Again, your curricular expectations start cascading out of the richness of the task. We launch the learning by inviting the students to immediately predict, speculate, offer their initial ideas, and we create those conditions for the sustained inquiry. Because they're not going to be able to answer this question in a day, right? It's non-Googleable, right? It's a non-Googleable. They'll come back and say, you were right, I tried to look it up and the answer doesn't exist. So we create these non-Googleable questions with rich mathematics embedded in them, right? And again, that becomes the driver, not the proof, not the thing, okay, we're going to learn all this stuff and then at the end you're going to do something cool. Let's put the cool thing up front. Let's put the cool thinking challenge up front and then support the thinking. Right? And you'll see a student here. Of course, I do have permission from her parents. I've got signed permissions to use these pictures, but you see an example right there of the kind of speculation and iterations, the iterative thinking that's going on as she's continuing to think through the challenge in her thought book. right? Or also adapting. This is for grade 7 measurement, adapting Dan Meyer's water tank problem, which is a grade 10 problem, but you can adapt it. So first day, there's a little film, and it just shows water starting to fill up this tank. It doesn't show it filling up, it just shows the first, I think it's the first 30 seconds. And the question is, how long will it take to fill this water tank? And of course, that is involving volume and rate. And again, really rich mathematics to come out of that. And you let the thinking be messy, right? And you help them understand that anyone who's really thinking about a rich challenge, whether it was J.K. Rowling writing Harry Potter, or Newton developing his ideas, or Kurt Cobain writing his lyrics, like whenever anyone is really engaged in a challenge, it's going to be messy, it's going to be iterative, you're going to revise, you're going to make mistakes. And we see that research continuing to be supported about the value, the profound value that mistakes provide for our learning, right? That they're not, mistakes aren't something to be just tolerated, but they're something to be really celebrated and encouraged. Okay, and again, you see some of that iterative thinking as the student's trying to think this through. He's creating those spatial representations, trying to visualize and represent this problem in different ways to find an entry point to understand it. I've also taken, I wanted to show you, this is from UCubed. A number of you might be familiar with Jo Buller's wonderful website, and if you're not, I highly encourage it. She has some fantastic films that I love using in my class, very student-friendly. And she also has rich tasks, but I want to just point out to you how I tweak her tasks as well to invite the thinking. So this is what's the secret code, and you see all of the requirements that are here, the numbers between 8,500 and 8,800. But notice what I've done is the instruction is what I've tweaked. Carefully consider, okay, so there's some thinking, there's some criteria. Carefully consider the following requirements to determine an accurate code number. So again, I just bumped it and tweaked it a little bit to keep the thinking, right? To say to them, what does it mean to carefully consider the requirements? Again, trying to put the focus on the type of thinking, the habits of mind that are needed. There's another great website, and Michelle's going to put the link here, coming out of Simon Fraser, and he's got some great rich tasks. But again, what I do is I take the task and I always tweak the invitation to bump it up for more critical thinking. So here, instead it was, okay, determine 2 people for a game of pickup, or divide the teams. But I take that question, I tweak it, and I say create the most fair teams of 2 people each for a game of pickup. So this is a great activity around number sense, and it's just the warm-up. He actually has a larger task with a number of people, and you have to divide them up to create 5 fair teams. So again, you can take existing tasks, and once you understand the frame of a critical thinking question, you can just bump it up. And lots of rich mathematical thinking comes out here. And again, very relevant, real world. So again, I'm going to ask you right now, just take a moment, and this time just 2 minutes, to consolidate at this moment, to revisit your question about what an effective inquiry might look like in mathematics. We'll just get 2 minutes. Okay, so some members just written in the chat box want to share their thinking. So Deanna has mentioned demonstrating an understanding of the processes and strategies being used, not demonstrating rote learning. And Diana has mentioned real-life, authentic tasks that allow for development of an elegant strategy. Thanks for your thoughts. Okay, so just thank you for just taking that time just to reflect on what we've done so far. So another principle when we're designing an effective inquiry is that we're shifting the focus of assessment from the right answer to the quality of the thinking, to well-justified and well-thought-out explanations, and to expert use of the evidence. In this case, talking about mathematical evidence. So here's some ideas about how we use those tools, the intellectual tools, and frame them as a lens for assessment. So we're thinking about, can a student draw upon accurate and relevant mathematical information? Right? And if not, what's the gap? Right? What are they missing in terms of the background knowledge? Can students make reasoned judgments using the relevant criteria? Do they actually know, can they determine what an effective strategy means or a reasonable solution? Can they use the key concepts that are related to mathematical thinking, like evidence, justification, proof, strategy, right? Can they actually employ useful strategies to work through the task? So we saw some examples in a thought book of students using some diverse strategies to help them solve the challenge. And really important in mathematics, it's those habits of mind, right? We talk about this, helping students develop the stamina to persevere through the cognitive demand, right? And it is that zone that someone mentioned earlier of productive struggle. And how do we nurture the kind of tools, those habits of mind that support them to persevere, right? To have the stamina for a productive struggle. And we're going to talk about, the three most important habits of mind in mathematics would be perseverance, attention to detail, and open-mindedness or flexible-mindedness. Right? Those three habits of mind are so critical for success in mathematics. So again, just returning to this student's work and thinking about the assessment, thinking about how we could frame those thinking tools, right? And look and see the thinking tools at play in her answer here. Right, so even that first line, the distributive property makes solving equations more elegant, clear, and overall makes the equation possible. So how is she using criteria there? Does she understand the criteria? Let's see, what are her justifications? What kind of mathematical evidence? What kind of conceptual understanding is she bringing to the table as she's justifying her rankings in this case? Right? And you see that when we're starting to design our task, we actually are surfacing this thinking, right? We're creating opportunities for this kind of thinking to surface. And then we can, we've been giving guidance along the way to support it and nurture it so that when they're finally in an evaluative situation, bringing it forward, they've gotten lots of feedback, right? So that we can help them really understand. This is something that hangs in my classroom all the time, criteria for an effective solution. And we've spent a good amount of time unpacking this. And I have to say the quality of student work has gone up so much because this criteria has become internalized for students. right? It's become internalized, whether it might be a quiz, it might be an in-class problem that they're doing, and then a solution that they might be handing in or communicating, or when they're critiquing each other. They're now very comfortable using this criteria, right? It's become that has become automatic to them, right? So it's important that not just the multiplication tables become automatic, but the mathematical processes, right? This is the criteria that we'd want for effectively communicating and reasoning, right? So we're trying to build automaticity in the strength of those processes. Yes, I think there's a question. Oh, is there a question? Please go ahead if you have a question. Feel free to ask your question if you've got one. The other key principle is that we're using the concepts and the cognitive dimensions of the discipline. So again, thinking like a mathematician to inform thinking about the engaging issues, actions, challenges, and situations. So I wanted to point out, this was a study that was done, a research paper. And we're seeing this, right? We're seeing the evidence of this shift in how we are approaching the teaching of mathematics. We're understanding that being a good mathematical problem solver is as much a matter of acquiring the habits and dispositions of interpretation and sense-making as of acquiring the particular skills, strategies, or knowledge. So it's also the stance, right? The habit of mind, that the way of thinking, the disciplinary thinking, the qualities of a good thinker. This is just as important as the stuff, right? The content and the concept. So they really need to be taught together. They can't be separated. And again, when we're thinking about that quality mathematical thinker, we are we're thinking about how we are nurturing those mathematical processes, right? What kinds of invitations for students to communicate, and how are we supporting their communication? What kind of opportunities are we providing for students to reflect, to connect, to represent, to solve problems, to reason, to prove, and to select tools and strategies, right? So we're really thinking about these dimensions as we're designing our tasks. To really understand the mathematics, what our students experience has to be consistent. I think this is part of the shift with the way that mathematics is done by mathematicians, right? We're seeing this in history, the historical thinking, in geography, the geographic thinking around patterns and trends and spatial significance and interrelationships. But students have to experience it in a way that how do mathematicians, right? Not as just something that is rote, but the real kind of beautiful thinking, powerful thinking that they engage with. So how do we nurture that? We want to be paying attention when we're designing an effective critical inquiry. How are they thinking like a mathematician through the inquiries that we design? Okay. Here's a sample of some of the things that successful mathematicians do. And I just wanted to, for me, I have found it so helpful to make this explicit and make it explicit not only for myself, but for my students, right? To help them become aware and to use this language and to create the expectation and to facilitate opportunities for students to be engaged in these kinds of thinking tasks. John Vanderwall, I think, really said it best. And I think we've such good intentions as teachers, and I've been so guilty of this. right? I do too much of the cognitive work for my students. And I've really had to unlearn that, right? I've really had to unlearn that and shift my stance and ask really good questions back to them that are actually nurturing their capacity to decide. And now what I say to them is, when they say, is this right? I'll say to them, you need to be convinced before you can convince me that you are right. And so the cognitive demand is on the student as opposed to me being the arbiter of whether something makes sense or not, which I think we've kind of exhausted ourselves a lot of the time doing that. Because the truth is, we cannot think or learn for our students, right? Only our students can do that thinking. So our job is to help make that more explicit for them. I find Alan Schoenfeld's 3 prompts for metacognition really helpful. And I sometimes create cue cards for some of my students who might struggle with thinking through a challenge. And we sort of create a little cue card with these questions on it. What are you doing? Why are you doing it? How is it helping you? Right? And if it's not helping the student, right, helping them understand, oh, this strategy isn't leading anywhere, right? Or what am I doing? I don't know where to begin. Right? Just helping them become more metacognitively aware of what's happening when they are engaged in the challenge. Okay? And again, just coming back to these things that a successful mathematician does. This is not an exhaustive list. This is just me pulling a few things for us to think about, right? When we're designing these critical inquiries, and how are we nurturing, inviting this kind of thinking. Thinking about those 3 challenges I've mentioned, the algebra challenge, the water tank problem, the Guggenheim inquiry, right? And thinking about how those challenges might be inviting this kind of thinking. Versus thinking back to that type 1 question about prime numbers. What kind of thinking is that utilizing? Where does that question belong? Does it belong as we're trying to maybe just activate some of the background knowledge, right? What are the kind of questions that are going to nurture the mathematical thinking? The other thing that we need to do when we're engaging in a critical inquiry, and you saw that with the algebra challenge, a lot of the students were intimidated. So then what we need to do is ensure that students have that sufficient background knowledge to be able to engage in the rich inquiry. So this comes back to the question that the teacher mentioned earlier about, like, I want my students to do this, but like, I don't think they know how to enter into that problem. So then how do we scaffold them? So here what we see is when students, I want to point out your attention, when students don't have a high degree of skill and aren't being challenged, they're pretty apathetic towards learning. When students have a low level of skill and are being challenged, what we're nervous about is they get really apprehensive and anxious about learning. The sweet spot we want to hit is over in the top right quadrant, that orange, really dark orange sweet spot, where they're developing the skills and they're being challenged and they feel interested and successful, right? That's the kind of sweet spot of engagement. So when we design these challenges, we have to make sure we're building their skills along the way, or, you know, sometimes it might feel like we've got to keep them on the raft with us. We're going over some rapids and we have to keep them on the boat, you know, and just to stay and persevere and develop that kind of thinking through the inquiry. So we want them to be learning those basics, but through critical inquiry. So what does that mean? Right? The math facts are really a small part of mathematics. Math actually has not a huge number of facts as another discipline might, But what it does have is it has incredibly rich connections between those facts. It has a depth that can be explored. So I just want to give you an example, and this question comes from a fantastic site, Open Middle, that is founded on the work of Dan Myers and Joe Bowler. And again, I just tweaked the question that existed and made it a critical thinking question by asking students, what are some useful strategies, understandings, and approaches that will help us solve this problem? And here they need to use the digits 1 through 9 to create 3 equivalent ratios. Well, now this is a really good challenge for intermediate students. So how might we build background knowledge in a critically thoughtful way? So I just want to show you an example, some concept attainment strategies that really help that. Okay, so we're trying to help students, first of all, understand what's a helpful or useful strategy. But then we want to take them, we want to let them speculate, give them some examples. Well, hey, you could use the scale factor. You could think in terms of halves and find equivalents. A strategy could be crossing off the digits 1 through 9 as I use them. So again, we're just surfacing some entry points to the challenge. But how are we going to build their background knowledge of the actual mathematics? So, we let them speculate, we let them surface their thinking. We're getting a lot of good information as they're making a first attempt. It's giving us some rich information about where they are. And then we might enter in with, for example, a concept attainment chart and say, here's an example. Here's some yes examples of equivalent ratios, because that might be the sticking point for a lot of students. What's an equivalent ratio? I don't remember. I don't know. I don't really know. Right? And concept attainment strategies, which I'm sure a number of you are using, but they're such powerful ways of learning the basics, right? Like learning, instead of giving the definition of an equivalent ratio, students have to think through, what are the characteristics of those yes examples? What are the characteristics of those no examples? Okay, and then we can unpack some of the attributes or properties of equivalent ratios through what surfaces in the concept attainment strategy. And again, we get such rich mathematical information, such rich basic background knowledge about equivalent ratios, and then some strategies, and it can emerge through a powerful number talk that comes out of that. So again, we've given them a challenge, and then we're building their background knowledge, and then we're getting them to go back to the challenge with their new understandings, revisiting it, making those connections. Oh, okay, well, I started with these 2 numbers. Now I'm going to see. Now I have a strategy, a way I can create, look for the denominators being equivalent to the antecedents. So that is, when I learned this, I thought it was so cool how, for example, if you have the ratio 1 to 2, and you're trying to figure out if it's equivalent to 4 over 8. Now, this is very easy for us to see that really clearly, but I just want to give a very basic example. But basically, the consequence forms an equivalent fraction with the antecedent, so the numerator. So notice the numerator 1 and 4 becomes 1/4, right? If we created a fraction out of the numerator, it would be 1/4, and then it creates the equivalent with an equivalent fraction with the denominator 2/8. And I didn't know that strategy for a really long time. Like it just wasn't something that I had learned, and it was like so illuminating for me. All of you might know it already, and I might be the outlier here, but when I discovered that strategy, I thought it was a really, really cool strategy. Right? And the other one as well, the sum of the numerators divided by the denominators should be equal to any of the ratios if they're equivalent. Right? So you notice that 1 plus 4 is 5, and 2 plus 8 is 10. 5 over 10 is 1/2, so it's equivalent. Therefore, those two are equivalent as well. Okay. So again, you can pull that out and get them to return to that original challenge of building the equivalent ratios with the numbers 1 through 9. right? And coming back to the original question, which strategy was most useful? They're thinking through. Okay, and again, returning back to this algebra challenge, we then did some concept attainment. Laura Ginny Newman came to my class and we did a concept attainment lesson around like terms, and also used another great tool is using an anticipation guide, right? So you create a statement about some of the core principles of the mathematics you're wanting to explore, have them in groups making their initial predictions. What do you think? Do you agree? Do you disagree? What are your reasons? At the end of that lesson, individually, and they can hand this into you, and it's a great check, right? It's a great way of determining whether they, have gotten it or not. You get them to revisit their thinking. Do you still agree and disagree? And give us the justification. And the justification is based on the attributes that you unpacked for like terms. And so they build their capacity for understanding the attributes by saying that's got to be part of your justification. So they're learning how to justify based on the mathematics themselves. Okay, here's an example of the concept attainment that we did, right? For like terms, here's yes examples, here's no examples, here are the attributes, right? And then the students in their justifications on their anticipation guide at the end used those attributes to justify their thinking. Right? And we pulled out those attributes through the students, right, as we engaged in the concept attainment strategy. A really, really effective strategy for building that background knowledge. Again, with the Guggenheim, we're building background knowledge. We're working through conceptions and understandings about circles and their measurements and making connections. So you notice the second question, what's the most important connection between circles and the Guggenheim inquiry? So we keep revisiting. We're learning the basics. We're learning those core expectations within the curriculum, but we're taking it back to the original challenge, right? You'll notice I've got up there at the top, I've got some jump pages I've given students because I'm trying to build some of the background knowledge and automaticity, but within the context of a meaningful challenge. Right? And I wanted to show this. This is one of my students who was not engaged in mathematics. And his mother actually emailed me and said, I don't know what has happened, but he was like dancing around the kitchen table when he was solving this problem when he got it, because he felt like he had accomplished something. Right? And that's what happens. That's the kind of engagement that can happen when they get caught up in it. That becomes meaningful in some way to them. So, and again, at first, I just want to tell you my journey with this student, because at first he was a student who, when he got the right answer but he didn't get full marks because of the criteria for an effective solution, he was upset, right? He's like, well, I got the answer right. And so there was that unlearning, and then to see him really internalize the criteria, you can see the quality of work that he's really done on this problem. It was really an amazing moment, right? Really wonderful moment. And finally, when we're designing these effective critical inquiries, students are exploring the issues and ideas in mathematics with persistence, attention to detail, and an open mind. And we're explicitly nurturing and talking about those habits of mind. And I wanted to share, right, so Carol Dweck talks about how our task as educators is to really facilitate the growth mindset in the classroom. And when students feel safe, they begin to leave their fixed mindset. So you think about the story I told you of this student who was like, well, I got the answer right, so like I don't know what you're talking about with effective solution stuff. Doesn't it matter that the answer's right? But it happens, right? When we're giving students meaningful work, when we give them honest and helpful feedback, when we give them advice on future learning strategies and we give them those opportunities to revise their work and show their learning, it's amazing what starts to happen. And so just to close this portion of looking at the critical inquiry, I wanted to share with you a student's reflection on the algebra challenge, because this for me was really, it was a really powerful moment. So I'm not going to say too much. I'm just going to invite you, there's a series of slides. I'm just going to invite you to read about her reflections on the experience. When you finish reading the slides, you just want to put a little check mark so I know that you're done and I can move on to the next one. And my students do refer to me in my context by my first name, just so that might be strange for some of you, but in my context they do refer to me by my first name. Okay, so I think I'm okay to move forward. I'm sorry if I'm not. There will be PDF of slides of those who don't quite finish. So again, it continues. So she was clearly really had a lot to say about the experience. And again, if you could just put a check mark so I know if you've had a chance to finish reading. This is grade 8. This is grade 8, and this is, again, if you knew the student, she's had, quite a journey. Okay, and I'm just going to move on to the final slide here of her reflection. So we're trying to think about how what we're teaching through the mathematics transcends the classroom, nurtures that kind of thinking, those kinds of competencies that are going to open doorways for our students, help them realize their potential, and also create thoughtful and thinking citizens, right, who are able to analyze data and search for credible evidence and be able to make reasoned judgments. So we're also nurturing our, the citizens of our society. Right? What kind of thinkers do we want? So I know we're running out of time. So maybe after, just as we close, you might want to take a little bit of time at the end and just any final thoughts to consolidate your thinking that we've done through our journey tonight. I wanted to point out that you can check on our website, tc2.ca, under partners, whether your school board is a partner of the Critical Thinking Consortium, and if they're partners, you can sign up for an account using your work email. If your school board is not a partner, you can buy an individual membership for $40 per year, and it does give you access to resources beyond the firewall. And we do have some tools for thought that specifically relate to mathematics behind that firewall, and I just wanted to point those out in case you might have a membership and weren't quite sure what's available. I encourage you to check those out. We've got a few tools like visualize a math problem, analyze a math problem, write reflectively, monitor problem-solving progress, organize data in a table. Inference is there, but you can use a math example with that lesson, just tweak it a little bit. We've also written some tips for teachers on mathematical reasoning that I've had Michelle include tonight, and it will be in one of the links. So I just wanted to let you know that this is a resource that is available and that you might be interested in checking out. Just kind of going through these ones quickly. And just my contact information. Please feel free to email me at any point if you wanted to discuss any ideas. I'm always really happy to hear from you. And I just want to thank you. I hope that this was worthwhile and meaningful for you, and I really appreciate you coming out tonight. So thank you very much.
Thank you, Maria. This was again an unbelievable session. Of an exceptionally high level of skills, creativity, and participation. I'm not a particularly sport-oriented person, but when I sometimes see some athletes at the pinnacle of their art, like Roger Federer, for instance, on grass, I can't help but equate the perfection of the movement to poetry in motion. I think that's what people say, it's poetry in motion. And it's always how I feel when I listen to Maria. I think that we can all agree that tonight we witnessed pedagogy in motion, I guess. Thank you, Maria, for helping us all move forward and becoming better teachers. I think that we were all jumping around the kitchen table tonight, and what you are teaching us is definitely not Googleable. I also want to thank all of you for being such incredibly motivated participants and dedicated teachers, and for your participation tonight. And a special thank to Diana for helping us sharing whiteboard entries. Diana, you are a very fast thinker and also a very fast typist. I've been moderating for OTF for the last 2 years, and I'm always astonished by the sharing of intelligence in these sessions. So it's really a privilege to be part of these evenings. Thank you once again for your enthusiasm and for your contribution. And I must confess that I have a bit of a family emergency here at home tonight, and therefore I'll have to make my conclusion very short and sweet. So let me quickly move forward. Here it is. Let's have a quick look at some of the sessions we have planned for the coming days. On March 8th, Laura Ginny Newman will be back for the second part of her presentation, creating a thinking classroom for primary mathematics. Laura and Maria are both members of the Critical Thinking Consortium, and they work together on the same type of challenges. So if you enjoyed Maria's presentation tonight, you will very likely be interested in Laura's session next week. On March 22nd, Matthew Aldrich will also be back with a new presentation from counting to multiplication. If you enjoyed his presentation on spatial reasoning last month, you may want to register for this one as well on March 22nd. And then on March 29, the power, something completely different, the power of materials in learning by Tessa Efferman. Tessa is a brand new facilitator to OTF Connects, and I certainly look forward to working with her on her presentation. And I'm going to quickly paste the links in the chat room in case you want to access our calendar and resources. Well, I also would like to tell you about another opportunity provided by OTF and the Ministry of Education. If you are a qualified teacher and completed an additional qualification course in mathematics, technology, or kindergarten, you may be eligible for a $450 subsidy. So I'm going to paste the link in the chat board as well for you to apply for that subsidy, that small subsidy. And as you may remember, at least for those of you who have been in previous OTF Connect sessions, we really value your feedback. It's very important to us. When quitting Blackboard, you will be presented with the opportunity to give us your feedback on tonight's session and fill a short online questionnaire. And as usual, we will also offer you a certificate of participation to this training session that you will be able to add to your professional resume. And if you don't have the time to complete any of this, or if you missed anything, don't worry, because we will send you a link, an email, follow-up email tomorrow with all the links to the presentation and to whatever was shared tonight. And I'm going to also paste these two links in the chat box for the feedback survey and the certificate of participation. I also want to provide you with the link to the resource page for Maria's presentation tonight, and it will be live tomorrow morning. So that's where you can find all the information and all the resources that Maria shared with us tonight. So that's it. Finally, I would like to invite you to follow OTF on social media as well as on our OTF website. I will now end the recording of the session. Thank you once again for your participation in tonight's session, and we certainly hope to see you on OTF Connect very soon. Bonne fin de soirée à tous et à toutes, et à très bientôt sur OTF Connect. Merci beaucoup.